we will look into some common CSS length units and how they operate. I will zoom in a little so that it's clearer. Here is our HTML code. The focus here is the div of the class container, which contains 3 divs. Each of the internal 3 divs has 2 classes. The first being box, which they all have, and the second being either px, vw, or em. We will see what is implemented in those CSS classes. Let's start with the container class. It has a font size of 1 em. Normally we use 1 pixel, but this is em. Em is equal to the computed value of the font size property of the element. I know that looks like a whole jargon, but em is the computed value of the font size. The computed font size of an element by default normally is the font size of the parent. So if I say 1 em, that will be the font size of the parent because that is the computed font size of the parent. So 1 em is the font size of the parent times 1, which is the same. So let's say the font size of the parent was 10 pixels. 1 em is 10 pixels. 2 em is 20 pixels. Do you get the idea? Now, in this example, since the div container does not have any parents with the specified font size, the computed font size will be that of the browser default. Now, that is 16 pixels. The browser default font size is 16 pixels. Do you doubt me? We can confirm this by inspecting the elements and checking the font size. On my browser Safari, I click on Inspect Elements and review the font. You'll notice that the default size is 16 pixels. Take note of that. A similar thing can be done in Chrome by right-clicking and checking the Inspect Elements. When you hover over the boxes, you should see the font size specified. We can see the code in the box class. We have a solid border, 3 pixel thick, with a Dodger blue color. Internally, it has a light pink background. Next, we have a px class demonstrating the pixel length unit. It has a width of 200 pixels. Remember, this is an absolute length and a fixed value. It will occupy a width of 200 pixels on our web page. Since we are in responsive design mode in Safari, I can select different screen resolutions. I will stick with the 800 by 600 resolution. That means we have 800 pixels to work with horizontally. So if I have a box of 200 pixels, the first div box, it will cover about 1/4 of the viewport width. This is because 200 is 1/4 of 800. So 200 the width of the box and 800 the total width of the viewport. So what happens when I change the width of the first div to 400 pixels? You will notice that it covers about half of the total viewport width. That is because 400 is half of 800. The same can be observed if we made it 700 pixels. It will occupy most of the viewport width and about 100 pixel space left. Unless I change the resolution to something higher. Let's reset it to the original value of 200 pixels. A common length unit you will come across is the viewport width. This unit, 1 VW, represents a percent of the viewport's width. In our example, the total viewport width is 800 pixels. 10 VW is 10% of 800 pixels, which is 80 pixels. Do you doubt me? To prove that the second div has a width of 80 pixels, we can edit the first div and change its value from 200 pixels to 80 pixels. That way we can see that the first div and second div will align because they have precisely the same width. We change the width and voila, we notice that the first and second div have the same width, 80 pixels. We can go ahead and reset them to their defaults. If I dynamically increase the resolution, you will notice that the second div, which works with the viewport width length unit, increases to maintain that 10% measurement. So it will always be 10% of the total viewport width. So as the viewport width increases, naturally it will increase to maintain the 10% measurement. Now that the viewport width is 1200 pixels and the div's width is 10 VW, it will be calculated as 10% of 1200, giving us 120 pixels. Now, if we change the first div back to 80 pixels, you will see that they no longer align as before. And this is because the second div has increased in width. To confirm this, we can make the first div 120 pixels and check if they align. Seeing them align proves that the second div increased to maintain the 10 VW length unit specified. This explains why they are called relative lengths and not absolutes. The next length unit is the EM. The container will inherit the browser's default font size 16 pixels. The child elements of the container div will further inherit that font size and apply to all the text. Our code here didn't specify a font size for the HTML body. A change in the font size of the body or container will reflect in the three divs. The length unit EM represents the computed font size of the element. This could be a font size specified in the element or inherited if none is specified. The container has a width of 1 EM, which means 1 times the computed font size. In this case, that is 1 times 16 pixels. The three divs all inherit a 16 pixel font size. However, the third div uses this to calculate the width. The width is 10 EM, meaning 10 times the computed font size, or 10 times 16. So the resulting width is 160 pixels. Do you doubt me again? We can prove that by making the first div 160 pixels and checking if they align. To further prove that it is calculated based on font size, we can change the font size of the container to 20 pixels. This will cause the 3 divs to have an increased font, which is normal. But you also notice that the length of the third div increased. The width of the third div is 200 pixels, computed from 10 em. Of course, we can prove that by making the first div 200 pixels. Feel free to try this out, and hopefully you can now better recognize and tell how the width is calculated anytime you see these units.